Okay, so now let's look at connecting our sensors. Here is our microaccelerometer with its cable. So we'll first connect the cable to it. And we have got beeswax at the bottom of the accelerometer, and you can ask Mr. Breitenbach to supply you with that. And that is very useful for attaching an accelerometer. There are different options of attaching your accelerometer to your structure, and please refer to your vibration notes as to what is more appropriate, but generally for field tests, non-invasive, best approach is to use either beeswax or super glue to attach your sensor. So I'm going to use my accelerometer as my reference sensor, so we place it here at node 26, and we're going to connect it to channel 1. Now please note that my logger has not been switched on yet, and that's a good practice. So we're first going to connect it and then switch on the logger. Next is our hammer, which we connect with a BNC cable to channel 2. And then we switch on the analyzer. At the back there's a blue button which you press and it beeps, and we'll give it a couple of seconds just to connect with the computer. Okay, now that our sensors are connected to the analyzer is switched on and connected to the PC. We now need to launch NVGate so that we can start looking at the actual data acquisition. There is a button over here to launch NVGate, but I'd rather do that manually. We launch NVGate. This is the screen that we are presented with. Office is useful if you want to do post-processing, but that's not what we want to do. We want to use our analyzer. So we're going to select that and press start. Okay, so we're not going to press any buttons here. We're just going straight back to the OROS software, and now we click this button. It has already been launched, and yes, that's connected successfully. And you can see over here connecting to NVGate completed. Okay, now we need to look at several issues to get us going. First, we can see here at channels, software is now connected to our OR35 analyzer, showing us our 8 available channels, although we're only going to use channel 1 and 2. Currently it's showing measurement set number 2. Let's take that back to 1. Now there are several options that we do need to look at before we start testing, and this action panel over here, firstly, very important, it's showing us the channel statuses of channels 1 and 2, so green is good. A red will show us if a channel is overloading, etc. There is an option to do auto run, so after you've excited your structure 5 times, or after you've obtained your 5 averages, it will automatically move the get the software ready for acquisition of the second or the next node. Generally, I would not recommend this, just because you can easily lose track of where you are measuring. So I'd rather not use that. You can, in terms of accepting a hit, you can use normal, but I typically would suggest using a overload rejection. So if your hammer or other your accelerometer overloads, you want to discard that measurement. Double hit rejection, very important for hammer, because with the hammer excitation you generally want a nice single clean pulse applied to your structure. Manual accept is useful if you work in or do a test in industry where you really need to manually define which hammer heats are acceptable or not, but we're not going to do that just now. So the next step that's very important is display and save. The default is not to save anything, so the rationale is that you will complete your test, the data stored in memory, and then you transfer it to the Modal2 software. Generally, I would not recommend doing this. The reason for this is that if your test is interrupted for some reason, you can potentially lose all your data. So rather press save, your trigger block. So this is your raw time data. It will store the 5 sequential averages that you've measured. You can also select to save H1 FRF, and we definitely want to save that. And there's a whole bunch of options. We can also tell it to save coherence, etc. But I'm just going to keep it at coherence, FRF, and trigger block, and we can just display or tile our windows, and let us just display our node numbers here to make sure we're measuring at the right locations. Okay, so just a note on using a modal hammer. It's important, as I've mentioned, to have a single clean pulse to your structure. So something like a double heat or multiple heats like that, where the tip of the hammer impacts the structure several times, is not good. So typically you want to hold the hammer, especially the small hammers like this, very lightly, and you almost want to start pulling back before the hammer hits the structure, so relying on the inertia of the hammer to keep it going. So typically the hammer will be like that, so you pull it back so you get a nice clean pulse. Okay, so now what we need to do is define the ranges of our sensors. Both are currently set at 10 volts. And let's decrease the hammer range to 0.6 to make sure we get proper triggering. The accelerometer, let's make it 1.75 volts for now. And we're going to first test at location number 1 just to make sure everything is correct. So let's see what happens. So you can see here that our accelerometer overranged, displayed by the channel status, and the software rejected that measurement. Oh, so I can see my measurement range was totally wrong. So let's just increase that, make it 3.16 volts. Let's try again. Software is still rejecting that, so let's increase it even more. And there we see the software is happy. We have our coherence displayed over here, a nice and clean, well-defined FRF. We can see our accelerometer response here with our exponential decay because it's impact excitation. We have a look here at our impulse from the hammer. If you zoom in, you can see it's a relatively clean pulse. So now we can continue. And I also just want to demonstrate the double hit rejection function, so let's give it a double hit. can see the software rejected the double hit. And you can see what effect the double hit has on the FRF. And you can see it's quite a good functionality of the software to have. So what I'm going to do is I'm going to continue with the test and get back as soon as I am done.